Assalamu alaikum. Today we're going to learn quadratic sequences. Quadratic sequences are the ones where the first difference is not common but the second difference is common. Okay, let's take an example and we're going to learn how to find out the nth term of a quadratic sequence using the form method without the formula and then with the formula, both the methods. Okay, let's start with this. This is a quadratic sequence. The reason being, if you find out the difference between the two, okay, the difference between these two is 9. The difference between 18 and 31 is 13. The difference between 31 and 48 is 17. The difference between 69 and 48 is 21. Okay, if you look at these differences are not common. Okay, let's find out the difference now. Between 9 and 13 it's 4. 13 and 17 is also 4. Difference when I say, meaning the bigger number minus the smaller number in this particular case. 21 minus 17 is 4. Okay, now whatever is the common difference, you just have to divide, which is the second difference. Okay, the first difference was not common, the second difference is common, which is 4. Divide 4 by 2 and you get 2. Write 2n square here. Okay, we know that firstly you have to take n as 1, then you have to take n as 2, n as 3 and plug it into this and write down the numbers. Okay, so n is 1. If n is 1, 1 square is 1, into 2 is 2, n square is 4. If n is 2, then n square is going to be 4. 4 into 2 is 8. If n is 3, then n square is 9. 9 into 2 is 18. Okay, if n is 4, then 4 square is 16, into 2 is 32. And if n is 5, 5 square into 2 would be 50. Now I'm going to copy the same uh, the original sequence here on top of it, and I will find out the difference between the two. Okay, that means this number minus this number. Okay, when I'm saying difference here, that means the number on the top minus the number underneath. So this is 7, this is 10. If I'm subtracting, 31 minus 18 is 13, and this is 16, and this is 19. If we know, now in this case the difference is a linear sequence. Why? Because you are adding 3 each time to get to the next term. So it's a linear sequence, and we know how to find out the formula for the nth term of a linear sequence, which we have learned in the previous video. Okay, so let's find out the formula for the linear sequence. Since this number, which is the common difference is 3, so we're going to write 3n here, and we'll take 3 into 1, 3 into 2, 3 into 3, 3 into 4, 3 into 5, so on and so forth. On top of this, we will take the original sequence, which was 7, 10, 13, 16 and 19. 7, 10, 13, 16 and 19. The original sequence is formula, whose linear sequence, the original linear sequence is formula we are finding it out. Okay, this minus this. Okay, if you notice, when you subtract, you're getting a 4 each time. That means you have to add this 4 to this number. Okay, and then add it to the quadratic thing. So it's going to be overall 2n square plus 3n plus 4. This is the formula for this quadratic sequence. In order to check, I'm going to plug in n as 1 and see whether I'm getting the first term of the sequence, and then I'm going to plug in n as 2 and see whether I'm getting the second term of the sequence. Okay, if n is 1, it's 2 plus 3 plus 4, which is 9. Okay, if n is 2, 2 times 2 square is 4, into 2 is 8, plus 3 times 2 is 6, plus 4, which is a 18. Okay, so the first term is also correct, the second term is also correct. Now we're going to learn the formula, the second method, which is using the formula. What is this method? To finding the nth term of a quadratic sequence. Okay, what is the formula to find out the nth term of a quadratic sequence? The formula is a plus d n minus 1 plus c upon 2 n minus 1 into n minus 2. Okay, I'm just copying the sequence underneath here. This was the sequence. Okay, I'm defining the terms here. A is the first term of the sequence. First term of the sequence. Okay, D is the difference of the first two terms. Just the difference of the first two terms. Okay, and C is the common difference, which is also the second difference in case of quadratics. Also the second difference. Okay, in this particular example, the value of A is 9 because 9 is the first term of the sequence. Okay, the value of D is the difference of the first two terms, which is also 9. Okay, and the common difference which we had seen was, the second difference which was common was 4, so the value of C is 4. We're going to plug in this into the formula. Okay, I'm rewriting the formula. A plus D n minus 1 plus C upon 2 n minus 1 into n minus 2. Achha, one thing which I want to tell you is that if you want, you in place of n minus 1 into n minus 2, we know when we multiply n minus 1 by n minus 2, n minus 1 by n minus 2, so n into n minus 2 minus 1 into n minus 2, we are going to get n square minus 3n plus 2. Okay, so if you want, you can replace n minus 1, n minus 2 by this also. Okay, so I'm just plugging in the values here. A is 9, D is 9, n minus 1, C is 4 upon 2 into n square minus 3n plus 2. Okay, let's simplify this. 9 plus 9n minus 9 plus 2n square minus 6n plus 4. Okay, 9 and 9 will cancel out. You're left with 2n square plus 3n plus 4, which is exactly the same as what we get when we did it with the other method. Okay, so this is the formula to find out the nth term of this sequence. Let's take another sequence. Okay, let's take another sequence, example number 2, which is 6, 10, 15, 21 and 28, so on and so forth. Now if you notice, let's find out the differences. The difference here is 4, the difference here is 5, the difference here is 6, the difference here is 7, and now the common difference is actually 1. Okay, if I use the first method, I am going to the common difference is 1, so 1 divided by 2 is going to be half. So half n square. Let's find out the first term. When you plug in n as 1, you will get half. When you plug in n as 2, so 2 square is 4, 4 divided by 2 is 2. When you plug in n as 3, so 3 square is 9, divided by 2 is 4.5. Okay, when you plug in n as 4, 4 square is 16, divided by 2 is 8. These are the terms. Okay, now we're going to copy the original sequence on top of it, which was 6, 10, 15 and 21, and we will subtract from this number. We have to subtract this number, subtract the 2. I'm getting a 5.5 here. I'm getting a 10 minus 2 is an 8. 15 minus 4 is 10.5, and then 21 minus 8 is 13. Okay, if you notice that this is making a linear sequence, because when you're adding 2.5 to 5.5, you're getting an 8, and when you're adding 2.5 to 8, you're getting a 10.5, and when you're adding a 2.5 to the 10, you're getting a 13. That means it's a linear sequence. Now we have to make the formula for the linear sequence. Okay, since we have to add 2.5 each time, so I'm going to write 2.5 times n. So the first term will be 2.5 times 1, and then 2.5 times 2, and then 2.5 times 3, which is a 7.5, and 2.5 times 4, which is a 10. Okay, then I'm going to copy the linear sequence, the original linear sequence formula I'm finding out, which is this one, on top of it, which is a 5.5, 8, 10.5 and 13, and find out the difference. So this is going to be a 3, this is also a 3, this is a 3, this is a 3. That means 3 is the difference. So the formula is going to be 2.5 times n plus 3 for the linear sequence. Let's check it whether it's correct for the linear sequence or not. When you add 1 to it in place of n and add 3 to it, you should get the first term. 2.5 times 1 is 2.5 plus 3 is a 5.5. Very good. 2.5 times 2 is 5 plus 3 is 8. So that's correct. So you just have to get the quadratic sequence, you just have to take the quadratic part, which was half n square, and that add the linear part to it, which is 2.5 n plus 3. Okay, so 2.5 is 5 upon 2, so I can write 5 upon 2 here. If I want to check whether it's correct or no, okay, so this is the final answer to this using this method. Now if I want to check whether this is correct or no, if I'm going to plug in n as 1, if I take n as 1, I'm getting 1 upon 2 plus 5 upon 2 plus 3, which is which is exactly 6. And if I take n as 2, I'm going to take half into 4 plus 5 into 2 into 5 upon 2 into 2 plus 3. If I simplify this, I'm getting a 2 plus 5 is a 7 plus 3 is a 10. So this is also correct, this is also correct, it's correct. Now let's do the same example, which is 6, 10, 15, 20, 21 and 28 with the formula once again. This is the second example of a quadratic sequence which we are doing here. Okay, let's write down the formula. The formula is a plus b times n minus 1 plus c upon 2. You can directly write n square minus 3n plus 2 here. A in this case is a 6. D in this case is the difference of the first two terms only. Okay, just the difference of the first two terms, which is the bigger number minus the smaller number, which is 10. Difference in this case will be a positive number only. The bigger number, whichever is the bigger number minus the smaller number. And the value of c is the common difference, which was 1. Okay, the second difference, which you can see here, the second difference was common, which is 1. So that's why we're calling it a quadratic sequence. Let's put it in the formula. Okay, so a is 6, d is 4, n minus 1 plus c is 1 upon 2, n square minus 3n plus 2. Okay, let's solve this. 6 plus 4 n minus 4 plus half n square minus 3 upon 2 n plus 1. Let's solve this further. Half n square minus 3 upon 2 n plus 4n plus 6 minus 4 plus 1. Half n square. 4 minus 1 and a half is 2 and a half. So plus 5 upon 2 n. 6 minus 4 is a 2 plus 1 is a 3. So I'm getting exactly the same as what I got previously using the formula. Thanks a lot for watching the video. Hope you've learned something.